We have seen earlier this inequality related to Reshma buying register and pen. So this is an inequality, and how we are going to solve it. Let us see the solution set first of all. Place x equal to 0. When we place x equal to 0, this will be 20y. So 20y is less than 120. That means y is less than equal to 6. So what are the values which are going to come if we consider the numbers non-fractional? It will be equal to 0, 1, 2, 3, 4, 5, 6. So all these are, means if we place x equal to 0, 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5 and 0, 6, all are the solutions now. And the other solutions of 1, when we place x equal to 1, x equal to 2, x equal to 3, will be what? It will be equal to 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 2, 0. Just you have to place this value which I am talking about here. X equal to say 1 and 2 and likewise. When you place the value in this equation, you get these value. So all these coordinates can be placed on a Cartesian plane like this. See, these are the values which we have just found: 0, 0, 0, 1, 0, 2, and like this. And then we have other values also, like the say 1, 4. 1, 4 is there, and we have 2, 2. We have, so these are the solution. But this can be extended, or we can extend this to real numbers. So we were talking about the whole numbers here, 0 to 6, but we can extend it to the real numbers. How we can extend these whole numbers into real number? We'll use the graphical way of solving it. So how we are going to solve it? The most convenient way is that the equation was less than equal to 120. Let us make it 4x plus 20y equal to 20. Well, let us convert it into the equality. So when we convert into the equality, we can easily make the line, because this is just like a line y is equal to mx plus c. So once you make the line y is equal to mx plus c, you see that it divides this plane into two halves. This is your second half, this is your first half. Okay, so we have two halves. When this line comes, or when we make this line, we have two halves. Now we have to find out whether this 0, 0 satisfy this or not. Let us put 0 and 0. What you are going to get, if you place 0, 0, we say, okay, 0, 0 is actually less than 120. If we go to the basic one, this one, we place x 0, y 0, and this 0 is less than 120. And when we place 0, we see that 0 lies here in the first plane. So all this first plane is the solution. All the points lying in the first plane is the solution. This is how we are going to solve it graphically. Okay, x 0 and y 0, it is actually satisfying the inequality. So all these solutions, this is the solution. But if we want the value to be positive, because you cannot have a negative value in this case, because Reshma cannot have a negative value of pen or negative value of registers. So we'll not go into the negative ones, but the below side of this line and the positive ones, means above this and above this. So this triangle is actually our solution. I hope you got the idea. This region is the solution. Let us take a few more examples to help us understand more. 3x plus 2y is greater than 6. We have to solve it graphically. Now this is 3x plus 2y equal to 6, which is a line. Now we are using a dotted line. Why? Because this is greater than 6, not greater than equal to 6. If you have greater than equal to 6, you are going to use a hard line. Means no dotted, you can make a dark line. But here, because it is a strict inequality, you cannot include this line in the solution. So now this line divides this plane into two parts. This is your first part, this is your second part. But if we place x equal to y and 0, which is lying here, x equal to y 0, what you get? 0 greater than 6, and this is false. So by virtue of this expression and this solution, we see 0 doesn't lie, or it doesn't lie in the first plane. So obviously the answer is the second plane. All the points here is the solution of this equation. Next, 3x minus 6 greater than equal to 6. Let us make 3x minus 6 is equal to 0. Actually there is no y, so it will be just x equal to this, x equal to 2. The solution is x equal to 2, so the line will be parallel to the y-axis. Let us place x equal to 0 and y equal to 0. Y is not there, so let's just put x equal to 0 here. What you get is x equal to 0. So you get 3 0, the 0 minus 6. Minus 6 is greater than equal to 0. This is false. So this 0 is not lying on this plane. So all the values here will be the solution. This is how we get the answer. Y less than 2, let us solve it. Y less than 2, and of course this y less than 2 means you are not going to include this y equal to 2 line, because we are actually going to make this y equal to 2, this line, and this we are going to make dotted. We are not going to make it hard line, because this is a strict inequality. Let us see about 0. Place y equal to 0. And we see if we place 0, 0 is less than 2. This is true. So this 0 is actually qualifying, or it is satisfying this equation. So this first plane, this is the second plane. This line divides this plane into this and this. So we see that because 0, 0 is here, all the values here is going to be the solution. And once we have done the single equation, we can also extend our discussion up to the two variables. Let us see. And we'll just, what we have done is we have made a line. And you have already seen how we made a line. So we'll make a line, divide it into 2. We'll make another line, divide it into 2. And the combination or the intersection of these two portions is the solution. Let us see how. X plus y is greater than 5. X plus y equal to 5 will take. So actually this is our line. It is having this as, say, plane 1, plane 2. Okay, this is the line. This is plane 1, this is plane 2. Let us take the line as x minus y equal to 3. This is the line. So what will be our plane? This is our first, say, third plane. This is our fourth plane. And as we say here, if we place the 0, 0, or we find out that when x minus y is less than or equal to 3, we are talking about this area. Okay, this area. When we are talking about x plus y greater than or equal to 5, we are talking about this area. So this area and these two regions, when this all and this all, when we combine, we get this region. So this is the intersection of this region. This is our solution. Okay. Let us take one more example. 5x plus 4y less than or equal to 40, x greater than or equal to 2, y greater than or equal to 3. Make it x equal to 2. So x equal to 2 will be like this, parallel to y-axis. Y equal to 3. So this will be the line, y equal to 3. Okay. So everything has to be above this. Okay, this. Now let us make 5x plus 4y. This is 5x per 4y. And we are going to get the values which are less. But it has to be confined between these. This is the solution. This is the solution region. So in many practical aspect and in practical situation, you are going to see this happening in various number of work and official usage or manufacturing usage. This becomes very important. So let us take one more example of that. Say x is greater than or equal to 0, y greater than or equal to 0. Number of hours work, number of unit produced. This is always greater than 0. So this is x greater than or equal to 0. So you will get only the solution in this xy plane. So this is the plane. All point here you will get the solution. But we have 8x plus 3y is less than or equal to 100. So what will be the answer? This. Because anything cannot be, we cannot take these points. Only these values can be solutions. So the triangle shaded region is the answer. Let us take one more example. X plus 2y is less than or equal to 8 and 2x plus y is less than or equal to 8. So this is the 2x plus y is equal to 8 line. This is the x plus 2y is equal to 8 line. But it has to be above x. X has to be equal to greater than or equal to 0, and y also needs to be greater than or equal to 0. So when we combine this is the quadrilateral which is the solution. Okay. So this we have seen a certain idea aspect of how we are going to solve this linear equality in two variable and one variable using your graph or diagrammatically. Okay. So we'll take one more of this chapter. Thank you so much. Take care of yourself.